This activity is about purifying water. And this is extremely important because in many parts of the world, people get sick from contaminated water. There can be small microorganisms that make us sick. There can also be pollutants in the water that are toxic. And to do this activity, you have to do a few practical preparations. First of all, it's a good idea to start with discussing with your students what are microorganisms, what are bacteria. And maybe they are aware that they have bacteria, for example, on their skin, that's not dangerous, that they have a bacteria in their guts that help us digest food. Maybe also some of them have become sick from drinking bad water or eating bad food. And then you can ask them, can we see bacteria? Are they visible? And they're not, they are maybe a few micrometers big. So before we can see them, we need at least 100,000 or maybe 500,000 bacteria together in what we call a colony. Then we can see them with our own eyes. And in this activity, you will purify dirty water and you will see if you're able to remove bacteria. So before we can do this, we have to understand how we're going to grow bacteria and count bacteria. And we will use something called a Petri film. They are thin sheets. And I suggest that you hand this sheet out to all your students to make them feel and touch it, and not at least open it here and touch the underneath here. And explain to them that this dry substance they feel here, it's actually a dry gel with a lot of nutrients that bacteria living in water love. So if you add water here with bacteria, the water will make the gel swell and the nutrients will make the bacteria thrive. So then one bacteria can become 2, and 2 bacteria becomes 4, 4 bacteria becomes 8, and so on. And ask them, how fast do you think this happens? And help them realize that actually bacteria can divide as quick as 20-30 minutes. Meaning that if you start at 12 o'clock, 12:30 you have 2 bacteria, 1 o'clock you have 4, and so on. And it's actually quite fun math to do this multiplication by 2 many times together. Just to realize that if you do this today, already tomorrow you might have colonies here with 500,000 or 1 million bacteria. And then it's also wise to show how the film is used. We are going to add 1 milliliter of water to each film, and we lift it up like this. We don't touch it now if we have a new film. And we need just 1 milliliter of water. That's like, this is a 1 milliliter pipette. And we add it here in the middle as one big drop. And then we just place the top over and squeeze very carefully, not too hard, because then we will squeeze the water out of the film. And it's just going to be like this. You have to hold it flat, but I'm just holding it here to show you. But it's going to be like this, and you just lay it somewhere warm in room temperature until the next day. And actually next morning you might not see anything, but very often in the afternoon you can see dots coming up. Maybe you have to wait 2 or 3 days. It all depends on the temperature where you are. So that's how you use the Petri film. And then we will move on to how to purify water. I have made this dirty water by just mixing some soil outdoors with water. And at the same time I have clean water from the sink, clean tap water. And we will purify the water using small columns with sand and some cotton at the bottom to prevent the sand from sliding through. And actually this way of purifying water is very often used in, for example, refugee camps, etc. Sand can be a very good material to purify water. So what you need now is to show your students step by step how to put up a basic column, and then maybe they want to develop this column further. Maybe they will try different materials in the column or do something else. But what you do is that you cut the top of the pipette like this. You take a small piece of cotton and you put that in the bottom with this stick here, and then you just add some sand to the column. And keep a little room left on the top so you can have some space to add water. And when we will purify water, we will send it through this column and into a clean tube. So this is the way to purify water. But as I said, maybe your students want to have or they have other ideas. For example, maybe they will say that, well, I want to take it outdoor and see if ultraviolet light from the sun can kill bacteria, for example. Or maybe they want to test other types of material in here. Another thing that's very often used to kill bacteria and other microorganisms in water is chlorine, because that's what we have, for example, in swimming pools and also in drinking water. So this is also something you can test here. For example, you can take several samples through your column, and then you take 1 and 1 milliliter, and maybe in 1 milliliter you have no chlorine, then you add 1 drop, 2 drops, 3 drops, etc. But the idea here is that your students will work in groups and have one leader that coordinates all the ideas that the other students have. If you feel that your students not are mature enough to organize this, you do it all together, step by step. It's actually a very good idea when you make the first column, you do it together step by step. And you also help them put out the first, or make the first Petri film together. For example, you can say that now we're going to test what is the bacteria in clean drinking water, and you just add 1 drop, 1 milliliter. Every group adds 1 milliliter in the middle at the same time, like this. And you carefully push down the top to make the water spread evenly on the Petri film. Because then they have all seen how to put the water on the film. And then you make the column together, and then you can let them loose, or you can guide them through the whole experiment. And now I will start by adding dirty water on the top of this column. And I can see it starts to go through. And then they have to wait a little. But in the meantime, they can make more columns and add water to them. Maybe they also have different ideas of water samples they want to investigate. But I will now make 2 samples with the same type of water and the same type of column. And then I will check if I add chlorine to one of these purified water, how that affects the amount of bacteria. And then I want to give you a little tip. If you look at these two columns, the water is running faster in this than in this one. And that's due to that here I used a rather small piece of cotton, but a much larger one here. So I suggest that you are careful that your students only use a small piece of cotton here, so it doesn't take too long to get the water through. Okay, now a few days have passed, and these are my bacteria films. And as you can see, there are several colonies on all films. This was the unpurified dirty water, and here I have a lot of small dots. And each dot is one colony. And of course they have a huge competition here in getting nutrients, so they don't grow very big, these colonies. After this water was purified through sand, however, there are far fewer colonies, and these colonies have really grown to a much bigger size than these. And then I added a few drops of chlorine, and you can see now I only have 3 colonies. So chlorine really killed a lot of these bacteria. One thing that's important when you have grown-up bacteria like this, you no longer open the film, because then you can get in contact with bacteria that you really don't want to get in contact with. When you put these in the trash, you put it where things are to be burned. So that's the best way to get rid of these.